Hello everyone, Mr. Schultz here. Welcome to Integrated Math 1, and we're going to be talking about 9.4 measures of spread. Make sure that you complete this title. You put your first name, last name, and your period number up at the top. So, first things first, remember that range is the difference between the greatest and the least. So for example, if I have some data like 2, 3, 4, 5, 5, and then it goes to like 10, well, that's just 10 minus 2. The range is 8. That's it. Now we're going to be using that later when we're talking about interquartile range, so bear with that. So quartiles, we're going to do a little paraphrase of this. It's 1/4 of all the data, or 25%. So if I had 1, 2, and then I had a 2, 2, and then I had a 3, 4, and I had like 8 and 8, well, counting this up, I have 8 numbers. So if I was to break this up into 4 equal piles, these would be my quartiles. I have 25% underneath this one, 25% in between these two, 25% in between these two, 25% at the tail end right here. It's broken up into 4 equal parts. Now this is where it gets a little confusing. Like we don't call like this first part the first quartile. We call this dividing, like where it divides the two things, the quartile. And so we're like, hey, this is the first quartile, this is the second quartile, this is the third quartile. There's no fourth quartile, which is kind of weird. But let's go on. So we're going to talk about the 5-number summary. So with the 5-number summary, there's 5 things that we have to discuss. First one is the minimum. Minimum, that's the least. All right. The maximum, that's the most. Okay, remember the median is starts with an M, middle. And now we're getting into the tricky ones. So we have the lower quartile, or the first quartile. Oh, wait, let's go back. So the minimum, we're going to write in these numbers. I put 1, so let's label this. So the minimum is at the minimum, least point. The maximum is at this end. And the middle is in the very middle right here. Now, if we don't have an exact middle, we're going to take the 2 numbers and then divide by 2. All right, now we're caught up. Now, we have the lower quartile, or the first quartile. So that's going to be the middle of the lower half. So this is the median of the lower half. So that's right here. That's the middle of the lower half. Then we have the upper quartile, or the third quartile. Now, the median is the second quartile. But we don't really call it that because it's the median. It's more known as the median. So the third quartile is right here. And this is the median of the upper half. So as you can tell, there's 5 points right, and this is what we call the 5-number summary. Least, most, middle, lower middle, upper middle, done. All right, so knowing that, we're going to go over and start completing our work. Let's do it. So example 1, find the range of the data set. Well, we could put it all in order, and maybe we should. But at this point, we just have to figure out what is the least. Looking at this, 12 is the least. Now we have to figure out what is the most. 53. And now we'll just go 53 minus 12 equals 41. So now we should probably type up the range is 41 units. Done. That's it. Next up, we have exercise. Kent tracked his daily number of minutes of exercise. Find the range of the data set. Go ahead and pause right now, and I want you to figure out this data. All right, hopefully you paused it. So the maximum was 45. The minimum was 25. So the range is 20. So it is very imperative for you to write down this information, like to write it out, like say the range, like use full complete sentences. The range is 20. All right, let's go on in 3, 2, 1. All right, so now let's make some not dot plots, but box plots. Not to be confused with dot plots where we make little circles or dots. Box plots, we're going to make a bunch of boxes. So if you remember this from previous year, great. If not, let's do it. So determine the 5-number summary and draw a box plot of the data. All right, well, basically what we have to do is we have to put them in order. So we have 309, we have 311, we have 312, we have 314, and we have 399. In fact, if we wanted to, we could even do a dot plot on this. So don't tell anybody, but we're going to make a dot plot. And so when we do the dot plot, we're going to see, hey, look, this can tell us information. So for example, this is going to be quite long. So let's cross this off. 1, 1, 1, 1. And it looks like, hey, 312 plus 312 divided by 2 is 312. So our middle number is going to be 312. So now we have this point right here. We understand that it's going to go way, way, way over here to 399. We understand it's going to go not so far, so I'm going to kind of make it look a little like this. Now, what would be really good is if we actually made this on a grid so that we could make it seem more scalable right there. So this goes to 309. So we have our minimum, we have our maximum, and we have one of our medians. We just need 2 more for 5 summary. We have 3 of 5. Well, now we have to figure out what's the median number of here. So now this is why I only do 1 stroke. So now I can go like this and go, okay, 1, 1, and my middle number for this one is 311. So I'm going to put this right here at 311. Now I have to figure out the other way. So 312 and 399, middle number 314. So 313, 314. Now it's kind of like it, but not really. Like I could make it more accurate, but shh, don't tell anyone. All right, so now what we're going to do is, this is also known as a box and whisker. So we have a box, and it looks like we have little whiskers coming out. Now hold up in 3, 2, 1. I'm going to ask you to pause it, and I'm going to show the data in 3, 2, 1. Please try to have number 4 done in 3, 2, 1. All right, guys, so looking at this, this is our answer for number 4. We have our 5-point summary right here with our box plot. The only thing that I would want this to do is I'd probably want to make the number line go from 2 all the way to 18 so we can get a better scale, better version, better representation of the information. So the interquartile range is between the lower quartile and the lower median and the upper median. So we're going to talk about that for a second? So basically, if we look at this number 4 right there, it's between 5 and 17. What's 17 minus 5, everybody? All right, it's 12. So we need to figure out what the Q1 and the Q3 is before we can do anything else. And before that, we probably need to do the median. So let's do example 3. So I'm going to put this together and then go from there. All right, so I've arranged my data. Now, going through it pretty fast, I can figure out what is my median going to be, which is 43. Now I have to figure out what is my lower mean. So I can go the other way and be like, all right, add these two, divide by 2. Now I can figure out the other 2 right here. Okay, add these 2, divide by 3, or divide by 2. Sorry about that. So let's do it. So getting that, I get 34.5 and 59.5. So if I was to subtract these, I would get a data of 15. Oh, wait, not 15, 25. Because 59 minus 34 is 25, and 0.5 minus 0.5 is 0. So the interquartile range is 25, and that's where 50% of the data is. 50% of the data is within 25 units right there. And that's very important because why? We want to figure out where is most of the data, and we want to figure out where is it in the middle. All right, so I'm going to post the answer on this one in just about 5 seconds. So make sure you try to do number 6 by yourself in 5, 4, 3, 2, 1. Come on, guys. We just did this one, like, just up here. It's right here, and 17 minus 5 is 12. That's it. Once you get this information, you don't have to do anything else. Well, you don't have to do any other work. You just have to go 17 minus 5. All right, let's go on. Now we're getting into the tough parts right here. So standard deviation is going to be a little difficult. Let's first try to understand it. Try to understand it. Let's put a little exclamation mark. Maybe put a happy face. Go ahead and put a star if you want to as well. So standard deviation can be seen as the mean of the mean. Well, some people are like, well, I still understand that. Well, basically what you're going to do is you're going to find the square root of the variance. So you are going to figure out the square root of how it varies. Let's do an example. Now, seeing this step right here, it's really good just to have this, just to look at it, but we really should go through an example of it. So find the standard deviation of a data set. First, we have to find the mean. So I'm going to add them all up. 10, 21, 30, 36, 45. Now we're going to divide by 9. So the mean is 5. Wait a second here. No, it's not. I made a little error on that. I was kind of jumping the gun. There's 5 numbers. I kind of did like my little math dyslexia right there. I switched it up. So there's 1, 2, 3, 4, 5. So 45 divided by 5 is 9. There we go. Don't go too fast. So find the square of the difference between each data value, x, n. Well, basically what we have to do is we have to do a lot of little problems to figure this out. So hold up right now. All right, we're going to have 9, that's our mean, minus 10 is equal to, and then square it. Okay, well, 9 minus 10 is negative 1 squared. Negative 1 times negative 1 is 1. Cool. Next one, so that's this one. Done. Next one. 9 minus 9 squared equals 0. Because 0 times 0 is 0, okay? Done. Now 9 minus 11 squared, which is negative 2 times negative 2 is 4. And so on until we finish up with every single number. 3 squared is 9. And then 9 again. 9 minus 9 squared is equal to 0. So now that we've finished step 2, we found the difference between the values right here. Now we got to add them up. Okay, well, just nice helpful hint is if you already put it like this, you can make it a, standing up problem like that, and we get 10, 14. Okay, that was step 3 right here. Oh, well, let's write that 14 a little bit better. All right, so this was step 3. Now we're going to take the square, divide the sum. So step 4, divide the sum by the number of values in the set of data. Well, how many numbers were there? There were 5, not 9, Mr. Schultz, 5. So 14 divided by 5, well, that's going to be 2 point something. It's actually going to be, well, just get a calculator. 14 divided by 5 is equal to 2.8. So this was step 4. Now, are you seeing like why we kind of need this as we go through and we're like, okay, next step. Did we do it? Next step. And then finally, find the square root. So undo that and go back. Or just erase it. The final step is find the square root. So all we have to do is go to a calculator, click the square root button, and then plug in 2.8. And that it will tell us our answer of around, so it's going to give us a round number, 1.67. So this is our standard deviation for these numbers. Now we're actually going to talk about what is standard deviation, not now, but later. And it's like within 3 standard deviations, it's like 99.7% of all the data is within 3 standard deviations, which is kind of cool. And like science, there's some cool things with science, like with 5 standard deviations. So that means like 99.999, but we won't even get into that. All right, guys. Go ahead and do this one, but I'm going to show the answers in approximately 5, 4, 3, 2, 1. All right, so the standard deviation of number 8 is 2.83. All right, so in order for you to get credit for these other problems we're doing that I'm not really showing you, you're going to have to show the work on them and try to match them up. So if I don't show the work, I want you to try to do the work in order to show that it matches up. All right, guys. That's it for 9.4. I hope you guys have a wonderful day. Bye, everybody.